Hello, this is Sabir Malli. The topic of our discussion in this video is solving linear equation by elimination. We will begin this video by solving this 2 by 2 system, which has two unknowns, x and y, and there are two equations, x minus 2y is equal to 1 and 2x plus y is equal to 7. The fundamental step of the elimination method is to eliminate the first entry from the second equation. In this case, this is a 2x if the system is 2 by 2. To eliminate this entry 2x, we have to perform an operation. In this case, it will be a very special operation which we need to perform. So let me write down the operation and then I explain why we need to perform such an operation. So step number 1 is we will eliminate 2x and we will eliminate by performing the operation on equation number 2. And in this case, what we will do is we will take the R2 and subtract by multiplying 2 to R1 and then subtract from equation number 2. So in other words, we will multiply 2 to the equation number 1 and then we will subtract from the equation number 2. And if I do that, you see that I did not operate any operation on the row 1. So this will be same. But when I operate, I multiply the equation number 1 by 2, so will give you 2 here, that will be 4 here, 2 here. And then I subtract from equation number 2. This will give me 2 minus 2, 0. This give me 1, and that's give me negative 4. So here will be negative 4. So this will give me 5y. If I do the elimination, that will give me 2 and 7. If I perform 7 minus 2, that will give me 5. So that is the 5 here. So this operation, this is a very special operation which we perform. This help us to eliminate the first entry in the second row. So once we have done that, in the second step, we will do the backward substitution. Backward substitution. Backward substitution means we will solve the system from back to up. I will start with the equation y is equal to 5y is equal to 5. This equation by dividing 5 on both sides will give me 1. So that's my first solution, y is equal to 1. I will plug that solution back into the equation 1. That gives me x minus 2 times 1 is equal to 1. And this will give me x is equal to 3. So that's why it's called a backward substitution, because I plug back y into equation number 1. So this is the solution of system x is equal to 3, y is equal to 1. Now let me focus on this operation, how we perform that operation. And this is a really special operation. So as you can see that I multiply this 2, which is the important number 2, and I multiply that to the equation number 1 so that it produce here also 2x. So it's important that this x should be non-zero. If x is not 0, even if you multiply 2, it will not help you to eliminate 2x. So this has a name, it's called a pivot. Pivot is the first non-zero entry in row, first non-zero in row that does elimination. That does elimination. And that number 2 is called the multiplier to 1 because it helps us to eliminate that 2x also. So how you calculate multiplier, it is very important how you can calculate the right multiplier to eliminate that 2x. So it is the entry you need to be eliminated. So the definition is entry to eliminate. Entry to eliminate, divide by pivot. For example, in this case, L21, which is the multiplier here, is the pivot is 1 and the entry to be eliminated was 2. So the pivot is 2. For example, if you have a different system, so let's suppose you have 3x minus 2y is equal to 1, 5x plus 6y is equal to 7. In this case, your pivot is 3. You know, in this case, what is your first pivot? There can be more than one pivot also. The first pivot is a 3 and multiplier, which is a 2, 1, is a 5 divided by 3. That is the multiplier in that example. So the pivot in this case, as I said, the pivot in this example is the first pivot is a 1. This is also called a pivot. This is the first non-zero entry when the system has been reduced is also a pivot. The first non-zero entry in the second position. So in this case, 1 and 5 are the pivot of this system. Here I have one quiz problem for you to practice. The quiz problem is, what is the value of the multiplier to 1 in this system? The system is 5x minus 2y is equal to 1, 2x plus y is equal to 7. Pause the video for 1 and 2 minutes and practice on this problem. The failure. Sometime when we perform the elimination can fail. And in the following minutes, we will see that what is the reason and why the elimination can fail. So let's begin with this example where we will see that the elimination will fail if we perform. So let's try down the first step. In my first step, if I try to solve this system, I will perform to eliminate this 2x. So in order to do that, first I need to call what is a pivot. Pivot is 1, first non-zero entry in the first row. And what is a multiplier? 2, 1 is basically 2 divided by 1. So in this case, the multiplier is also 2. So my row operation, which is going to perform on R2, will be R2 minus multiplier L2 1 time R1. In this case, L2 1 is 2. So I will multiply this equation by 2. So if I perform this operation, so you will see the system is going to be look like this. This is going to be x minus 2y is equal to 1. I will not change anything in my first equation because there is no operation is applied on that. In R2, if I multiply this equation by 2 and subtract, this is going to be 2. This is a 4. This is a 2. So 2 minus 2, the first entry is 0. So 0x. Second is also 4. So it's going to become 4 here, negative 4. So if you subtract negative 4, that's going to be also 0y. And if you multiply this by 2, this is going to be a 2. 2 minus 7 minus 2 is 5. So as you can see, if I rewrite the system, x minus 2y is equal to 1, and then we have 0 is equal to 5. So the elimination failed because you will not be able to do the step number 2, which is a back substitution. In order to perform the back substitution, that number has to be non-zero, you know. So it means that number was a pivot, but it is not a 0. So you will not be able to perform the back substitution. So the reason is how many pivot we have in the system. In the system, we have only pivot x is at the very first place 1. The second number, which is supposed to be pivot but is a 0, we don't call if it is a 0, we don't say that number is a pivot. So we have one pivot and our system is 2 by 2. This is the reason why this back substitution, this elimination failed. That's the one way to fail the elimination. And you can see that here, so you have 0 is equal to 5, which is not a true statement. So the system does not have any solution. One good way to look at this system is why this does not have a solution. Let's try to draw the column picture of the system, and you will see that clearly the column picture will tell us the geometric behind why the system is failing. So as you can see, the first column of this system is 1 and 2, which is related to x, and the second column is basically -2, -4, and the diagonal column is a 1 and 7. So we're gonna plot these vector. 1 and 2 is like, suppose this is a vector 1 and 2, depending on the scale on your axis. And then you have vector -2, -4. So -2, -4 is somewhere here. It's just a double length. If you multiply that vector to basically -2, you get this vector. This is the same vector. So these two vector, these two column is on a same line. So this is the vector second, this is the vector first. And but this 1 comma 7, if x is a 1, y is a 7, is somewhere here. So there is no way you can draw a diagonal, which there is no way you can draw a diagonal out of these two sides. So if you take one side of this and this side, you cannot draw a non-trivial diagonal, non-trivial parallelogram, which this vector basically is a diagonal of that vector, you know. So this is the reason that it is a no solution, because this cannot be the diagonal. If you try to draw any parallelogram, this there will be no way you can make this as a diagonal. So this is the row picture. This is the column picture, which tell you that why the system is does not have any solution. The row picture also will tell you that why the system does not have a solution. In the row picture, there will be a two parallel line. If you draw the row picture, there will be two parallel line and they will never meet. So in that situation, the system does not have, the system has no solution. There is another way the permanent failure can happen with infinitely many solution. So you get the system as infinite many solution, but the elimination process fails. So in step number 1, so again, if I calculate in step number 1, what is my pivot? The pivot is 1, and what is the multiplier L to 1, which is also 2 divided by 1 is equal to 2. And if I perform the first operation is going to be on R2. So R2 minus this term, which is the multiplier 2 times R1. If I perform that operation, I'm gonna get x minus 2y is equal to 1. But from the second equation, I'm gonna get to 0 because 2x minus 2x is 0, and also minus 4y minus 4y is equal to 0. So 0 on this side. But in this case also, I'm gonna get 2 here, and that's the 2 here. 2 minus 2 is 0 over 0. So the second equation is true. So the second equation is trivially true. So the system has infinitely many solutions. However, this elimination process failed because again, we failed to find the second pivot. So the number of pivot here is only 1. So we have too few pivot. So we was able to perform the back substitution. But since the second statement is true, it means any number, any x and y lies on this line will give you a solution. For example, if I choose x is equal to 0, then y will be -1/2. That is a one solution, you know. And if I choose x is equal to 1, and in this case, if I plug 1 here, y is equal to 0, that is another particular solution. In order to write all the solution, so this is the way to write all the solution. You write x and y here, and you solve this equation for x. X is equal to 1 plus 2y. Therefore, I plug x is equal to 1 plus 2y. Y is a y. And we can basically write this system as a sum of this vector 1 comma 0 and then y time 2 comma 1. So this gives you all infinite many solution. Vector 1 0 time any constant basically y is now a term, take be arbitrary constant. This is the infinite many solution of the system. Also, you can look into a column picture and row picture and see that why the system fail, uh, and why there are infinite many solution. In this situation, what will be your column? This is your one column, which is at 1 comma 2. The second column is basically this, which is a negative 2 4, and you can see that 1 comma 2 is also lies on the same line. So all the three vector, the right hand side vector and the two column, they are on the same line. So this is the reason why the the system has infinite many solution. So there is a third way a system can fail to perform the elimination method, but this time we can fix the system. So here we have a system 0x plus 2y is equal to 4, 2x minus 4y is equal to 2. In this case, if we begin by substitute performing the elimination, you will see this is the element which is on the pivot position, but that element is 0, 0x. So we will not be able to take 0 as a pivot. So we will say, okay, we do not have a pivot in the very first position. But this can be fixed if I interchange the second row with the first one. So 2x minus 4y is equal to 2. And now we have a 0x plus 2y is equal to 4. Now the first pivot is equal to 2, which is a non-zero. And now you can basically find the multiplier. In this case, the multiplier 2 comma 1 will be a 0. So you don't need to perform any operation on the row 2, or you can say basically the operation on R2 will be R2 minus 0 time R1, which is the same, because this system is already turned into a triangle system. And you can perform the step number 2, which is a back substitution. You can solve y is equal to 4, gives you y is equal to 2. That is the first solution of your system. And then you can back substitute into the equation 1, which is a 2x minus 8 is equal to 2, which is equal to 2x plus 10. So x is equal to 5. So as you can say, x is equal to 5 and y is equal to 2 is a solution of this system. But this time we was able to fix the problem. We see that the 0 is in the pivotal position. So whenever you see the 0 in the pivotal position, if you can fix it by interchanging, then it is a good thing. So we can still solve the system. Here we have another quiz problem for you. So this is a quiz problem number 2. What type of failure we will face solving the following system? 3x plus 2y is equal to 4, 12x plus 8y is equal to 16. Pause the video for 1 and 2 minutes and work on this problem. The elimination method was first introduced by the Gauss. So this is also called a Gaussian elimination. If we truly want to understand the Gaussian elimination, we must solve a 3 by 3 system. So here I have an example of a 3 by 3 system in which we step by step solve the system by applying the Gaussian elimination. Okay, so for the first step to solve this equation is to find the first pivot. The first pivot is, you can see the first non-zero entry in the first row, the first equation, which is a 2. And then we will calculate, because we would like to eliminate 4x and minus 2x. So we will calculate 2, 1, the multiplier 2, 1, and we will also calculate the multiplier 3, 1, which will eliminate the third row and first entry, and the second eliminator, the multiplier, will eliminate the entry in the second row first column. In this case, the entry to be eliminated is a 4 and divide by pivot. In this case, the entry to be eliminated is a negative 2, it's divided by pivot. So that will gives you 2, this will give you negative 1. So row operation, so first or R2 will be performed. and that will be R2 minus the multiplier, which is a 2 times R1. And in R3, we will perform R3 minus multiplier. Multiplier is a negative one, so that will be positive one. So basically R1. So when we will perform these two row operations, this system will produce to 2x plus 4y minus 2z is equal to 2. And this 4, so here we will have 4, 8, 4, 4. So then we will, 4 minus 4 is 0, that become 8. So 9 minus 8 gives you y here. That gives you negative 3, and that gives you negative 4. So that gives you z here. And this is a 4, 8 minus 4 gives you 4 here. So that the first row operations, which give us basically y plus z is equal to 4. And R3, when we operate R3, we simply adding these two equations. That gives you 0 first, that gives you y here, that gives you 4z, and that gives you 12. So this is gives you 5z. So that gives you y plus 5z is equal to 12. So this is the first step of the elimination, is which sort of making. So this is the first step of the elimination is. Now let's perform the second step of the elimination. Again, we will find the pivot first. In this case, because we will leave this unchanged, this is the first non-zero entry in the second row. The second pivot is the second and first non-zero entry in the second row. That is a 1. This time we will eliminate this term, the second term of the third row. So I will apply second term of third row and then second term. So 3, 2. Multiplier will be, entry to be eliminated is a 1, pivot is a 1, so the multiplier is a 1. So we operate R3, which will say R3 minus 1 time R2. That will be the operation which will be operate on R3. So I will write 2x plus 4y minus 2z is equal to 2. And that will be y plus z is equal to 4. And if I operate that operation, that will gives me, so 1 minus r3 minus r2, this minus this is a 0, so this minus will give me a 4z, and this gives me a 12 minus 4 is 8. And the next pivot is this. This is the next pivot, the first non-zero entry. So I can write my pivot. How many pivot we have? Now the pivot are visible. This was the another pivot. That's the first pivot. So my pivot are 2, 1, 4. So these are the pivot in the system. Now let's perform the back substitution. If I perform the back substitution, from the very last question, because I'm gonna go back to up, from the last question, I'm gonna get z is equal to 2. If I plug z is equal to 2 here, I'm gonna get y is equal to 2 also. And if I plug z and y is equal to 2 in my first question, then I'm getting x is equal to negative 1. So this is my solution. X is equal to negative 1, y is equal to 2, and z is equal to 2 by doing the back substitution. So this method is called the Gaussian elimination method because this is first introduced by the Gauss. Therefore, this is known by his name, Gaussian elimination. This is also the end of the video. Thank you very much for watching. I will see you in the next video.